Welcome to Brain Vision.
For this question, we're looking at a water slide that was built in the past, and we're given that the height of this is 9.7 meters at the start, and the total length for the slide down is about 54.3 meters. We want to first find the speed of the sled and the rider at this point C, right, when it just hits the horizontal portion. Right, so we are given that the the slanted portion over here is frictionless, so we don't have any friction. So all the gravitational potential energy over here is converted into kinetic energy. Right, so the total KE would be the initial KE given to be a velocity of 2.5 meters per second plus the plus the gravitational potential energy that was imparted. So the gravitational potential energy is given as mgh. So the person is 80 kg times 9.81 times the height of 9.76 meters. The total kinetic energy, you should get about 7.9 times 10 power 3 joules. And from here we can equate this to half mv square to get our velocity v. It's 2 times the kinetic energy divided by m square root. And we should get a velocity of roughly 14.1 meters per second. Now, we are given that the total distance that the rider can actually travel after he hits the water over here is probably around 50 meters. So we want to model the water as exerting a constant frictional force or retarding force on the sled. So we get the force multiplied by the total distance traveled, which is 50 meters, must be equal to the total kinetic energy that it has, right, at the start, so that it can come to a stop. Right? So the total work done by friction must be equals to 7.9 times 10 power 3 joules, and therefore we can get the frictional force over here given as 158 newtons. But we are not done, right? This is the horizontal frictional force. But the water also exerts a vertical force, right, or a normal force to keep our sled afloat, right? And this normal force is equivalent to the weight of this of our craft or of our person, right? So in this case, it's just 80 kilograms times 9.81. So the perpendicular force is 80 times 9.81, which gives us about 784 newtons. So the net magnitude of the force exerted by the water is 158 square plus 784 square by Pythagoras theorem, right? Let me take the square root to get about 800 newtons. Now, the next part of this question, we want to find what is the force exerted by the chute on the sled, right, as it is sliding down, right, in this region, the slanted region. So as it's sliding down, the force exerted by the sled is a normal force in this direction, and this normal force is equal to the force exerted by our person, right, on the chute. And this is actually due to the components of its weight, right? Some perpendicular component of its weight, mg. So weight is this component, mg, and some component of it is perpendicular to the chute, and this perpendicular component corresponds to the normal force which the chute exerts on the person. So how do you get this component? Well, we will need the angle over here, the angle of this chute it makes, and we know that sine of this angle theta, right, this angle theta is given as 9.76 over 54.3. These are the lengths, right, the height and the hypotenuse. So we can get theta to be about 10.4 degrees. To get the vertical component, right, we know that the angle theta would correspond to the angle made over here. Sorry, not there. It's, the angle over here. So the vertical component would just be cosine, taking cosine of 10.4 degrees. Mg times cosine 10.4. This gives us about 771 newtons. So this is the normal force which the chute is acting on the person. For the final part, we are looking at the curvature, right, where the chute meets the horizontal portion. So we want to take this curvature part to be kind of like a circular motion, right, with a radius that is given as 20 meters. So radius of 20 meters. So at this point, it means that we will need a net force acting on the person to be mv squared over r. And we know that near the bottom over here, the velocity is given as what we have found earlier, vc, so which is the velocity at point C, which is 14.1 meters per second, right? This is 14.1 meters per second, and we know that the free body diagram at this point is experiencing its own weight. It is experiencing the normal force that we want to find, and the net force, which is the normal force minus the weight, must be equals to the centripetal force. So the normal force would just be equals to mv squared over r plus mg. Putting everything in, so we have 80 kilogram. V square is 14.1 square radius of 20 meters plus 9.81, and we should get about 1.57 times 10 power 3 newtons.